In this video, I'm going to explain how to make sense out of and reconcile the equations of John Bell with quantum mechanics. And I'm going to demonstrate it using David Merman's experiment. I'm not going to explain the statistical difference between John Bell's equations and quantum mechanics. This is aimed at serious researchers who already know what I'm talking about. In an experiment, you send pairs of entangled particles in opposite directions towards two measuring devices. And in each device there are three spin sensors which senses whether a particle is spin up or spin down. A, B and C, and they're all set at 120 degrees angles from each other. So if we look at spin sensor A, for example, and we use this schematic, anything above the black line is spin up, anything below the black line is spin down. And if machine 1 and machine 2 are both set to A, they will both record the opposite spin 100% of the time. So if sensor A is spin up in the first machine, it'll be spin down in the second machine, and vice versa. Now if we have two machines, one with the centre oriented vertically and the other one oriented horizontally, then in the first machine, if it records spin up, then the second machine will record spin up 50% of the time and spin down 50% of the time. Remember, if anything's above the spin line, it's spin up. If it's below the spin line, it's spin down. And we can say the same thing from the perspective of the second machine. If it's spin up in the machine, which is the 90 degrees angle from the first machine, then it'll be spin up in the first machine 50% of the time, spin down in the first machine 50% of the time. And if you were to overlay the schematic of those two machines, one on top of the other, you'll see that when one is spin up in machine 1, say for example, then it's spin down half the time and spin up half the time in machine 2. So when we get spin up in the second spin sensor, then in the first spin sensor we get spin down 50% of the time and spin up 50% of the time. It works both ways. And that seems straightforward if we take it at face value. So now let's overlay three spin sensors in a schematic. So the black horizontal line is the division between spin up and spin down for sensor A. The yellow line is a division for spin sensor B, and the blue line is a division for spin sensor C. So in effect, what John Bell argues is that if we use this pointer where one end reflects what's happening in machine 1 and the other end reflects what's happening in machine 2, then because we know we will always get the opposite spin, so spin sensor A in machine 1 is spin up a third of the time in the 120 degrees between the black line and the yellow line. The opposite end of the needle will be spin down for spin sensor B in machine 1, therefore spin up in machine 2, which is exactly what we see in the schematic. And of course the same happens for spin down. If it's spin down in machine 1, the other end of the needle will be spin up in machine 1, therefore spin down in machine 2. And then you have the two areas where you have a 60 degree angle between the yellow line and the black line. So in effect, what John Bell showed is that if we take everything considered as equal, then 50% of the time we take it from the perspective of machine 1, 50% of the time we take it from the perspective of machine 2. So if it's spin up in machine 1, it'll be spin down in machine 2. If it's spin down in machine 1, it'll be spin up in machine 2. So if we regard the full circle as the full time, then 1/3 of the time altogether, you're going to get opposite spins in the two machines in those two 60 degree zones, which is 1/3 of the overall time. However, that needle is representing two different directions from the perspective of one machine, but we're measuring with sensors which are set at 120 degrees angles from each other. So let's use needles which reflect the fact that the two sensors are set at 120 degrees angles from each other in the two machines. And let's take it from the perspective of sensor A and sensor B. And the orange zone in the circle represents the full time range for sensor A, and the yellow zone in the circle represents the full time range for sensor B. And when we do this, what we find is that because the range of the yellow between the orange part of the circle and the black line is a 30 degree angle, so when machine 1 is set to spin sensor A, a quarter of the time spin sensor A will be recording spin up, and spin sensor B will be in the spin up position in machine 1, therefore spin down position in machine 2. And of course the same dynamics happen if we take it from the perspective of spin sensor B or spin sensor C in machine 1 or machine 2. So if the two machines are set to A and B, for example, a quarter of the time you're going to get opposite spins recorded in the two machines. So the hidden variable is which perspective are we taking from, which spin sensor and which machine. So that should be pretty clear that the outcome is predetermined regardless of what perspective we take it from. The other question then is how can that information be travelling faster than the speed of light? And in my theory of everything, I show that the particle model can't be correct because for any interaction between any two objects, there must be a physical connection. You can't pull or push a car up a hill, for example, if you don't have a rope to pull it, or you haven't got hands on it to push it. You can't use a pump to pump up water if the end of the hose isn't on the surface or below the surface of the water. If it's above the surface of the water, if there's space between it and the surface of the water, it won't suck up the water. That's why the particle model can't explain gravity, because you need a constant connection. And I show that connection is provided by a string type lattice, and inside the string type connections there's a fluid flows and ether. And it is possible that electromagnetic radiation and gravitational waves are not the only kind of waves in the fabric. If we look at water, we have surface waves on the water. But if we equate them to electromagnetic radiation, we also have sound waves underneath the water. And we know that the sound waves travel phenomenally faster than the surface waves. And if the ether is a perfect fluid, it is theoretically possible that that kind of subtle wave can be moving so fast it is in effect instant between any 2 points within the universe. And I have an experiment to test the hypothesis. And if it works, it'll verify my theory of everything and reveal a correct model of physics going beyond the standard model, which will open up entire new fields of phenomenal technology. So if any researchers are willing to work with me, we'll run that experiment. All you need is a double slit setup with single photons or single electrons in a vacuum. It's exactly the same principle. When we detect for which way by firing photons between the slits, we're changing the perspective in the experiment. And I have an exquisitely simple way to prove it. All the evidence indicates that it will work. So if any researchers are interested in working with me, my email is skaggs, skagzxx @gmail.com or prof.diamond@protonmail.com.